A day in the life of a data scientist. My name is Sarah, and I'm a coach for data science and a freelancer at Malt. So, I own my own company, or at least I'm building up my own company called Sin Sugar. But I'm a data scientist for more than 4 years already. And in my previous company, I already did a lot of experience with a lot of different data science topics, and I did some experience with also leading some of the projects, and I would really like to share my experience with you today. You can find me on Malt because I'm also registered as a freelancer. And besides my job, I'm also organizing a tech meetup in Germany. I'm located in southeast Bavaria in Passau. I don't know if someone of you know it, but if you're from the region and if Corona times are passed by, we will also do some meetups for software development and data science, which is called League of Geeks. So, and before starting in the data science topic, actually, I just want to give you an overview what I'm offering at my company. So first of all, it's team coaching. It's about programming, statistical methods, tools, and how to organize your work. And the second thing is to optimize projects by doing some workshops. So I'm offering to find some use cases that are suitable for companies and to do prototyping and testing their ideas later. Yeah, for today, I will give a very short introduction to the topic. Then I will talk about skills and personality aspects that are required for being a data scientist. I will go into use cases, show you my toolbox and how to organize work, especially in teams. And the last point will be your questions. So, introduction. As I said at the beginning, I have been working as a data scientist for over 4 years. So I started in late 2015. And when I started with my former employer, it was called data analytics. But all these words seem to change like every year. So after being a data analyst, I switched 1 year later to do data science. But actually my kind of work didn't change that much. 1 year later, it was called machine learning, and 1 week later, it was called artificial intelligence. So as you see, we are really working in a buzzword bingo world, and it's really difficult to differentiate all these words. Of course, there are some differences, and I would never say that I'm really doing artificial intelligence. Also marketing says, but I would say data science is more like manually focused, and we are using a lot of statistical methods. We are using machine learning algorithms too, and sometimes it can be integrated in an artificial intelligence application, but artificial intelligence is something that is not so closely connected to a human being doing manually data science. So artificial intelligence is, for me, in my understanding, a standardized process, a standardized product used in manufacturing, which is scaled up and which is also used in connection with robotics. Nevertheless, I would describe myself as a data scientist with a lot of analytics and also doing some machine learning. But in the end, everything is about solving a problem with data. And I think this is the most important message. And for me, my most important mission. Nevertheless, how you call it, how someone else call it, this is the mission we have to solve. So before we start, I would like to ask you in a short survey, which skills needs a data scientist? And for this, I would like to copy this link, which is underneath here, into the chat that you can open it. And I would go to the web page. So Melanie, maybe is it possible that you share it to the chat? Okay.
Yep. Can you hear me?
Yes.
Okay, that works. Just loading it. Give me a second.
So, and now I'm going to the website.
You're sharing now?
Yes, I'm sharing down this website, right? Can you open the link? So this is the link. Oh, okay. So what we are seeing now, we are collecting your answers and getting a nice visualization. Okay. Python's competence, understanding, analytic, business, data. Okay, cool. Patience. There's someone with a lot of experience here in this call. Mention patient. Rules, thinking, Python, mathematics. Nice. Cool. I think I would like to stop it now because otherwise we will be out of time quite soon. But it's really nice to get all these interesting ideas from you because, yeah, it's quite similar to those skills that I have, yeah, that I have in my mind. And I go back now to my initial keynote presentation. So, and yeah, talking about the skills that a data scientist needs. So if you look at this page, it's a lot. So actually, I am differentiating between three parts. So first part on the left side are the core skills. So core skills are, of course, mathematical, statistical understanding, a little bit or a lot of coding. It depends a little bit if you're more on a technical track or if you're a little bit like the more generalized track. So coding, especially SQL, Python, R, or Spark. You need a lot of business understanding, but also visualization capabilities, how to visualize and how to express the results in a right manner. You need, yeah, some understanding how to use analytics tools. Tableau, for example, as a good visualization tool, but don't get me wrong, also Excel can be used to do quite basic and quite basic analytics and basic data science. So you can also start with it right away. For code organization, Git is quite useful. I will tell you a little bit more later. And to know how IT infrastructure is working, especially the cloud environment or how it works in cluster. You need some knowledge about databases and also how to fetch data, for example, via API, via interface. Most common ones are currently REST APIs. And yeah, you need some more methodology knowledge with machine learning and also to validate your results. On the right side, you will have the delivery skills. So besides the core skills, you need to know how to deliver your results. So project management is quite important. To have a feeling for user experience and user interface is very essential, especially if you are presenting or delivering your results in a way of a dashboard or an app. And you also have to be able to think in products or to think in end-to-end scenarios, because at the end you want to solve a problem using data. And you should have a delivery skill like being a consultant, because your client or the internal department is asking you for an advice and they want to be consulted by your experience. And the third aspect is social and communication. So one key aspect is being a team player, because as you see on the left and on the right side, there are so many skills to know to be a full data scientist, that you always have this, that you never be able to be a professional in every of these skills. So it's better to be in a good team and to be a good team player and to benefit from the talents that the others bring to the team. Furthermore, you need to have active listening skills. So being a good communicator and communicating peer-to-peer, so with your teammates, but also with your someone from business, for example, or someone who's not so keen to technology. And of course, presentation and storytelling skills, because the complete topic is very difficult and complex. And if you can compile it in a nice story, it's much more easier to understand what you want to say. So what is a data scientist? Is it a nerd, or what else is it? What kind of personality do you need to have, or what kind of personality does a data scientist bring? So actually, I would say it depends. It can be a little bit nerdy, but it also needs to be a good communicator. So definitely a data scientist has to love numbers, huge tables, and charts. And he or she has to be curious, very curious about the problem, and needs to be thrilled about the problem and to understand every detail of it. Definitely, it needs to be a problem solver, because at the end, there's a problem and you need to solve it. It's not good if you're a perfectionist and if you want to be to just do a nice code or write nice code or a nice model if this doesn't solve a problem. Definitely, you need a hacker mindset, because data are not easily available all the time, and you need to write, for example, a web crawler to get the data sources you need for your later analysis. Well structured, and you need a lot of empathy, I would say, because you're communicating with a lot of different stakeholders. But a data scientist can also be a little bit annoying, so sorry for saying this, because a data scientist asks a lot of questions, and can be really picky on the questions. It's not for being mad, or we don't want to be mad, but we want to understand it further, and we want to understand the problem and understand the data and want to make everything clear. So can be annoying sometimes. We are creative and sometimes innovative, because not every problem has been solved before. And I think some data scientists are very excited about their discovered insights. So even though they are not completely meaningful for everyone, even though the result is sometimes not something that the business person has expected, but it can be excited anyway for the data scientist. Yeah, let's talk about some use cases. So if we are looking at a typical project timeline, and if you have read a lot in books or in journals, you will come maybe to those kind of representation of a project timeline. So you have a sequence of different parts of a project and you follow them along the time. So a project can be of 3 months, it can be of a year, it can be of more than a year, it can be of 3 weeks, for example. But it is said that every project has some kind of these elements inside. And it's starting with a scoping phase, so where you understand the problem and the project outcome. You go over with data cleaning, where you're transforming the data and you're correcting outliers and combining different sources. Then you do some exploratory data analysis for better understanding the data, finding relationships by understanding correlations of data, or doing some visual analytics. Then the third part is modeling, so going deeper into machine learning, where you're extracting features that are relevant for your model, and you're trying to create a model that is valid. So model training, validation, and selection is essential before you can go to the next phase to visualize your results. So make some interpretation out of it, build a dashboard, an app, or a charts. And at the end, you deliver your results, make some presentations. So the ideal project timeline. But when you have experience with data science, it never looks like this. So maybe the sequence from left to right is quite okay, but here in this visualization, you have the feeling that all these different sequences take exactly the same time, but that's not the case. Especially, I had made the experience that scoping is essential. So you should better take some more time in scope your project and define criteria of done and have a common understanding in the complete project group, so that everything what you're doing and delivering in the end makes sense for the company and makes sense for your client. On top, data cleaning. It is said that data cleaning takes about 20% of the project timeline, but that's normally not the case, because I have experienced that my clients said to me, yeah, we have some data here, we have stored it right away and it's super clean and you can use it and go further to modeling. It has never happened. Data is never clean. Don't believe what the client is telling you, or don't believe what the other department is telling you. Always check your data and be very suspicious about the data, because this is your baseline. If the data is not fine, you can throw away this complete project. It's I would say it's garbage. So it's not really useful. So keep this in mind, that this is a typical project timeline, but it's not true. Further on, I would say it's also not a sequence. It's always back propagating in itself, because after you have done your scoping and you start with data cleaning, maybe you will find out that the data is not fine for the scope you did. So maybe you have to do some adjustments in the scope or in the data sources that you have defined. And the same, and this is the same over the whole project timeline. So always have some increment idea in mind, so that you always can go back and redefine what you have done in the previous step. And what I would like to recommend to you is that you're trying to work through the entire pipe in a very short amount of time, and do this multiple times right away. So work in increments, work it through, and then you have a result. And from the result, you can readjust the scoping or the data you need. And then you have some technical baseline, and you can redefine it over time, and you will get better and better, I will promise to you. So never do it sequentially. So see this thing as a whole and rework it all the time. So one kind of exploratory data analysis I will show to you. I promised to David I won't talk about Corona, but actually because of current situations, I just want to mention to you that there are so many incredible data sources outside which you can use. They are freely available. You can use them. You can learn with them. And it's really interesting what you can do with it, only in the part of exploratory and explore the data. So one thing that I was exploring in the last days is, are the curves of the confirmed corona cases in Europe, in European countries, similar to each other? And what I've seen on, or what I've got is, I've got the original data from the Johns Hopkins University. And you can see an extract from the list on the left side. So you see there are different countries, you have the longitude and the latitude parameters, and then you have all the confirmed cases in each column. And this is how this data looks like. So pretty easy, pretty slim. But what can you do out of it? So what I did here on the right side is that I said, oh, it's interesting, but first it started in Italy to explode like hell, which is really, 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 yeah, shocking. It was really shocking to me, but actually I wanted to say, how does it work out for the other countries like Germany, Spain, and France? So I decided to take a look if the curves are looking quite similar, if you normalize them. So if you're putting them on the same base, so on the same time base, I decided to cut, or to let the curve start at this day when each country exceeded 200 confirmed cases. And from this, you can see on the right side that the curves are looking quite similar to each other, which is really, I don't know how to say. I shouldn't put a lot of emotions inside this, but yeah, it's quite interesting that they are looking similar. Hopefully, it's getting better over time, and I will check these data every day because I find it quite interesting. Yeah, a second use case is about image classification. So very advanced already because it's a part of computer vision. And I was asking myself, can a machine learning system recognize inappropriate images? And I think this is a use case which is really, really important on the internet, especially on platforms where users can upload images or other kind of content. So there's so much amount of data that people are uploading every day or every minute on the internet. And if you want to be a serious, very important that these, for example, platforms, work with algorithms against pornographic content, for example. And what I did here with a quite funny story is that I represented it in another way. So let me introduce to you Manu. Manu is a very good friend of mine. Manu is very obsessed about tracking himself. So he takes a photo of his face every day, I think since 8 years already. So he is collecting data like hell. And I found out something like this. So Manu is a very funny guy. He uses very different situations when to do a photo of himself. So he also do something like this, which I found quite interesting to test if a machine learning system is able to recognize inappropriate images. So inappropriate for me in this case means showing him half naked. And it was really interesting that the machine learning systems I used in neural net, I used quite simple setup with I say a basic neural network because I also wanted to get more into this topic. And it was quite interesting that you could get quite good results just from passing on some kind of data. So of course it's a bit biased because this data is only showing Manu, it's only showing my friend, so the system can recognize his face quite easily. But as you can see on the upper side, he's also doing some funny stuff, which makes it a little bit more difficult for a system to recognize. Nevertheless, it was a quite good experience and gave me confidence to progress in this, with this topic. yeah, about toolboxes and how to organize work. So for a data scientist, I would say you have a large toolbox to know and a large toolbox which you can use every day. So of course you have your IDEs or your, as I would say, your code space, for example, Visual Studio Code or PyCharm or Jupyter Notebooks, RStudio, Spider, Notepad++, whatever you want. So it doesn't matter. You have the analytics tools, I know Nime, Tableau, ClickView, Power BI, Excel, Google Spreadsheets, and so on. Then it's about Git. Git is the version control system of your code. It's especially useful if you're working in teams, but also to organize your code on a quite professional level. So for this, there are software providers like GitLab or GitHub or Bitbucket, which are using Git and provide you the software on which you can organize your code. Then product organization, tools like Jira, Trello, Asana. So now we are being a little bit more in the generalistic understanding of a data scientist that also has to organize himself, but maybe also teammates. And something like a wiki, which I use quite regular in my previous job, which it was Confluence, because we wanted to share our knowledge centralized and not to leave it in the heads of the people. So we were really, we had a high discipline to collected all the documentation of the projects and collected them into Confluence. But Evernote is also a good alternative. And then communication tools, for example, Slack or Microsoft Teams, but also as we do it here, Zoom, WebEx, or email are part of the toolbox a data scientist uses. And the third thing, which is really important and I would like to recommend to you to use, is some design tools, because as I said in the beginning, data science can get complex quite soon, and it's often, or it's critical to have a common understanding of the outcome of your analysis. Or if you think bigger, if you want to build an system that is taking data every day or every hour, processing it and forward it to a front end, for example, it already creating an infrastructure which can be quite complex. So designing tools like Mural or Draw.io or Balsamiq can be quite helpful to build some small representations of your IT infrastructure. I will show you later. So yeah, what I have highlighted here in the nice pink is that what I will show you now in a more detail. So the first tool that is quite recommendable to you is the Jupyter Notebook, because it combines documentation and coding in one document, which I find really, really nice. So you have the Python interpreter behind what you can see here, but the Jupyter Notebooks are also running with R, they are running with Julia, Ruby, and I think C++, but I'm not an expert in C++, so for me it's fine if I can work in Python or in R. And I like the Jupyter Notebooks because they are browser-based, and yeah, you can code and have your documentation right away, and it looks really professional and also nice for clients to view this. The second IDE is RStudio. Maybe some of you already have tried it out. So this is something quite typical. You have your script panel on the left upper part and the terminal panel on the right side. And what is quite nice with RStudio is that you have the global environment on the right upper side. So every part of the code which you are executed and every object that is stored in the environment will be represented on the right side. So it's quite easy to follow the steps, and it's quite easy to don't lose your understanding. The third tool is part of the Git part, so the version control system, and it's GitHub. So GitHub is, I think, can be quite difficult at the beginning for a starter, but I think it's worth it to learn it. So if I'm honest, I'm still at the beginning of learning to use Git as a professional, but I'm already found out that it's really, really, really helpful, especially if you're working in teams and especially if you have to coordinate. So if you're working on the same code base, or if you're working on more or less the same analysis, but you have different scripts, put them in Git, because it's centralized, it's running on a server, and if you're working in your home office right away, or if you're if you're not working permanently on the same project, it's really useful to have the data and the code and your results somewhere every of your team can enter. Because I think the worst thing is that someone gets sick for a couple of days or a couple of weeks, and the code is located somewhere on a local machine and no one can get it. So put it there, so you make yourself independent, or you're working independent from each other, but it's combined, or it has a centralized location. Where you collect all the status. And if the special thing is here, if you're working on the same scripts, it's definitely looking for what has changed. So you have your history, which is quite important if you do any changes. And it also checks for conflicts before you can combine the code. Yeah. The next tool I want to show you is Draw.io. It was from the part of the design tool. And what you can see here now is a nice representation of what I have, how I use Draw.io similarly. So it's especially useful if you want to display data schemes, if you want to display different tables that you want to connect from your databases. It gives you a visual representation of something that is not always easy to understand. I also mentioned before, it's really useful if you're working in a bigger environment, if you're building an IT infrastructure of your data and you want to understand and communicate it with others. It's really nice if you have a visual representation of everything. And for this, I can recommend Draw.io because it's also free. Or at least it's a freemium product. You can start right away. And I don't know, probably there's also some subscription part, but not at the beginning. Yeah. Now we're done with the tools, but let's go further with how to organize your work. So in my opinion, there are two different modes of how you work as a data scientist. So you have a deep focus time and you have a casual time. And I would say it's 50-50 balance, because what is deep focus time? Deep focus time is when I put on my headphones, I will really go into focus. I do this for programming. I do this if I'm really into an analysis. And I do it if I have to review the work of my peer. So it needs a lot of concentration and I want to be focused. It's less interactive work, means I'm putting away my smartphone. I'm deleting all the notifications, or I just block the notifications that I'm not getting distracted. And while I'm focused, it's really difficult to stop. It's a nice phenomenon, because if I'm starting with it, it's really like kind of an addiction, because I'm really digging deeper into the analysis and I'm getting my insights, and then I'm thinking about, oh, these insights are interesting, which lead me to the next idea I'm having. So the deep focus, it's a quite interesting experience you can do. Yeah, but it's not possible to do it more than 4 to 5 hours a day, at least for me. I don't know how you are working, but I find it quite intense. And if I do it, I cannot do it 8 hours a day. It's different to casual time because it's also important. That's for internal or client meetings. If you do brainstorming with your team, do some project planning, presentations, charts, and easy conceptualizing. So it's more the interaction and communication part. And of course, this can be done more than 5 hours a day because it's not that, yeah, it doesn't take so much of my concentration. But both of the time modes are quite essential and quite important. And in my point of view, the weight was 50-50 for both kind of modes. About teamwork. As I said in the beginning, there are a lot of skills you have to know as a data scientist. And I see myself not fully equipped with all of them, even though I have worked for over 4 years in this area. It's very difficult to be a professional in all of them. And for this, I'm always telling my clients and I'm always telling the companies, don't look for the unicorn. Don't look for the person that is probably perfect in all of these areas because you won't find them. Better invest in teams. So invest in a really good project manager, in a really good coder, in someone from the engineering part, in someone that has a scientific background or is graduated from a data science, IT, statistics faculty. So in my point of view, data science is a teamwork, and a data science project should be staffed with at least 2 persons. Better would be having 4 or 5 persons in a team. And communication is key. We talked about the nerd. We always think about a nerd as someone that is not so good in socializing. That's not true. That's not true. Even though if you're a bit nerdy and if you can find yourself excited with some data tables and with coding, communication is key and teamwork is key. So when you're working in a team, define your quality standards, define it within your team, and define your common documentation standards. So how you work, how often do you call each other? What are the criteria of done? When do you push your code to Git, for example? When do you do quality checks? How do you do it? It's very important. I do not have a recipe for you, but you should take this in mind, that you should define it with your teammates. Don't hide your work on a local machine. Yeah, as I said with Git, I think that's the worst case scenario, that you are hiding work on a local machine. Establish project routines. We did that quite often. We did some retrospectives, for example, every 3 months, which was quite useful because everyone had to give some feedback. And from this feedback, we could learn how to improve our team coordination and to improve with the way we work. And establish processes wisely, because only establishing a process is not the key to success. Processes can be good, and I know Germans love processes, but not every process is clever. So use them wisely. Think about which kind of process, which kind of routine is interesting to your team and is useful for your team, but don't use processes just to have them. It's not a good idea. And yeah, tools may help, like communication tools are very good helper. Like I like Slack, for example, because you can do very good screen sharing. Also use some tools, like some offline tools, like a whiteboard, to brainstorm your results. But if you don't have the right mindset how to use the tools, also tools are not helpful. So you have to define which kind of tools are right for your work and your team. Yeah. And about teamwork, or teamwork remotely, as this is something that is probably important for all of us currently. yeah, there are some requirements which have to be set up in the forehead before, especially it's a stable network or cloud infrastructure, because yeah, you need somehow the connection to get the data, and you need, it has to be secure. Think about you're working on a project for a customer that gives you high sensitive data, and it needs to be sure that this is that you're processing it in a secure manner. So yeah, and high computations should always run on a server. I think it's nothing which is surprising to you, because if you run it on your local machine with only 8 gigabytes of RAM, some model training will take forever. Communication tool is even more necessary and even more essential if you're working remotely, because yeah, if no one of the others know what to do exactly, you won't get good results. So routines like check-ins and check-outs, right, are also in data science quite useful. And I like the idea of pair programming or quality checks, and we also did that in my previous work at my previous employer, because we had different kind of office locations and our team were spread over the different locations. So we used a lot of tools to do some pair programming, so working closely together on the analysis and to check how check if the quality is on a high level. Yeah, and last but not least, the calendar of a typical workday. Of course, it's something that I constructed together with another data scientist. So if you're checking emails, your appointments for the day, then probably you will have a short 15 minutes team stand-up to coordinate what you are doing the day. Then you go into your focus time. So you're doing 2 hours of data analysis. Then also before lunch, you often have to coordinate with data experts because you have some questions. I told you we can be really, really annoying. So questions is something that we are asking a lot. So coordination with data experts also take about 30 minutes a day. Then we have lunch break. Then 1 hour more of focus time. Then what is also quite important is training. So yeah, training either alone or with your team. So having some team session and exchange your knowledge. Of course, short kicker match is quite good to have to get the mind free. Now when you're in remote, it's quite good to go outside and take a breath at the fresh air. And then you're going back in the data analysis part, so 1 more hour of deep focus. And the day ends with documentation and writing together all your results and communicating them to your project team lead or to your client to communicate what is the current status and how to develop in the next days. Yeah, a typical, there is no typical work day, of course, but probably to give you an impression how it could look like. Yeah, that's from my side. I'm happy to answer your questions now. So please, yeah, if you have questions, please write it in the chat.
I think there's already a first question that I received. It is when you describe the project in steps, it's kind of a sprint, right? In different iterations, and that sounds very agile. But what from your perspective are the benefits of working like that?
The benefits are actually that you will find out quite soon if your approaches are, if you're on the right track, if your approaches are correctly, you can adjust really soon. And well, let me explain from a different perspective. If you get data, you can analyze almost everything. you can ask so many questions about this data. You can easily train a model, but it doesn't make any sense if it's not valuable. It's not worth it for somebody to use it. And that's why I'm thinking of working in sprints. Also in data science is really, really nice, and also really beneficial for everyone. So what was really frustrating to me is when I put a lot of effort in a project and I worked many weeks and or maybe also months at the same project, and at the end the customer said to me, "Whew, yeah, nice results, but we cannot use it. We have no user for it, or we have not the infrastructure for it, or our goals changed meanwhile and we don't need it anymore." So this is something that we, or I at least, find very frustrating, and that's something that you can better get rid of this emotion or of a failed project if you're working with some agile methods. Don't call it agile, just call it that you're working incrementally, that you're presenting first results very, very soon. And then ask your peer, ask your project lead, ask your client, ask your ask someone that asks you for this analysis if this is already something that is useful, because it doesn't make sense if you put more effort in it if it's not really useful to someone.
Thank you. Thank you. We have another question. You talked about how scoping is super important to make a project successful. This is probably also true for other tech projects. How do you manage this with your clients?
Good question. We also, or I also started to use some HR methodologies like story map meetings. I don't know if you know about it, but if you're thinking of a good, or if you're thinking of the end product of a data science project, and probably you have to forget about these exploratory part, because it's not the end product of a data science product. So an end product is normally a model, a data science model, a trained model. It can be a dashboard which gets data regularly, or it can be somehow a digital product that uses data science in a way. So it's very important to find or to define a user story from the beginning. It's more like take some more insights and some more experience from software development and put it into data science, because this is something that I find also quite beneficial and which helped me in the past to be more successful with what I've done. And there are some, I do not have a good recipe, but I think a very intense kickoff workshop is very, very interesting and very beneficial to create a common understanding on the goals, and to also have these back propagations within the project. So always ask in between, are we still meeting the expectations? Are the results that we have so far, they are matching what you want to have in the end? Are we on the right track, or do we have to readjust what we did, or do we have to adjust our scope? And there are some methodologies, but I'm regularly used, or I used to use story mappings, and what I like to use more in the future is design sprints. So like a whole week of designing and writing a data science prototype and test it right after a week, and then having a better understanding what the idea is worth it.
Thank you. From your experience, like how you perceive the role of data science in the last years, how do you think will this role develop in the next years, couple of years?
Oh, I hope it don't get vanished. No, yeah, it's interesting. It's an interesting question. I don't know how to answer this. What I can say is that companies are still looking for really good data scientists. They need it. Probably not really looking for the unicorn anymore. So the high technical person having a statistical background and is really good in connecting business points together and is a really good communicator. So more, I think companies are more investing into teams, into really strong teams, and data science will be still very valuable, but I have the feeling it's divided more into subcategories like data engineering and machine learning engineering and deep learning engineering and the analytics part and the product owner part. So, but maybe it's a good development because, as I said, a data scientist cannot have all the skills. So hopefully I could answer this question.
Sounds good. And there's another question. I heard about two jobs, data scientist and data engineer. What is the difference?
The data engineer is something that is more as so other. I explain it in another way. 4 years ago, everyone was looking for a data scientist. I think companies hired a lot of data scientists. They took a lot of money to pay those people, and then they started the first project and recognized that they don't have the right infrastructure to get the data. So they don't have the right cloud infrastructure. They don't have the pipelines between the databases and the analytics environment. So they needed some more technical affine persons that are capable to solve these problems. And from this, the data engineer arises. So the data engineer, in my perspective, is even more technical than a data scientist. He has to know about how to bring together data, how to make those data sources available on high scale, to make it available on a regular basis and on a secure basis. And the data scientist for me is more the analytical part that is working with the data, is trying out different methodologies to better understand the data, and is more the communicator, who is communicating the result to someone that, for example, a client, is something I would perceive it.
Thank you. I just checked. Are there any more questions from the audience? Maybe one question coming up, because at the beginning we were asking like, who are the people in the audience? And there were many people who are just about to start with data science, so kind of new to that topic. What would you advise those people? Like, if they're interested in a topic, how to proceed on from now? What would you tell them from experience?
My experience is books are nice, but I think they not give you the right experience which you need, because the start can be right tough, especially if you're not a programmer. For me, for example, it was quite tough because I have a background in business administration and statistics. So I did a little bit of R programming, but I have no clue about IT and infrastructure. So this was something that I had to learn quite hardly in the beginning. I would recommend do some projects. Take real data. Look for data sources that are outside. There is the name open data. Almost some cities, some communities, some countries, they have platforms on which they are publishing some kind of public data, and you can use them. You can download them and you can start right away. You can do some online courses to get some quick start, someone that gives you a good introduction, what to do and how to start with coding, or you start with some Excel or Google spreadsheet, just to have, so it doesn't matter if you're coding or if you're using an analytics tool. Take whatever you feel most comfortable with and try out yourself and make the experience. At the beginning it can be quite hard, but it's worth it. After a while you will recognize that you make a lot of progress in your work. And the last thing I can recommend to you, take a look on kaggle.com. Those of you who are doing the bootcamp or are already data scientists may know Kaggle is a huge community and you can participate in competitions, but you do not have to participate in a competition. You can just register yourself and take a look how other data scientists are solving specific problems, because it's open to everyone and you can see the different the different contribution others did to a competition, and you can watch the code and also download it and try out yourself. So this is something probably the best you can do. Practice, practice, practice.